No. Okay, so welcome everyone to Safe Living Technologies millimeter wave learning webinar. Today we have Rob, Bruce, and Oram are all going to be presenting. Rob's going to do an introduction on the meter itself and millimeter wave. Bruce is going to give us some more insight on the development of the meter and millimeter wave technology. And then Oram is going to give you a very short presentation on the usage and all his findings in the California area. So it's should be very insightful for everyone. Okay, so Rob, you can start.
Okay, I will take control of the screen and just let me know that everything looks okay on your end. All good, Tony?
Yeah, looks good.
Okay, welcome everyone. This is the 5G millimeter wave learning session number 2. And I am Rob Metzinger, president of Safe Living Technologies. I'm an electronics engineering technologist, a BBEC, building and biology environmental consultant, as well as an EMRS, electromagnetic radiation specialist, and one of the senior instructors at the Building Biology Institute in the US, along with my other colleagues, Larry Gust, Mitch Marchant, and Oram Miller as well. My website is safelivingtechnologies.com or slt.co. And just a brief introduction to the Safe and Sound Pro millimeter wave meter that we just recently released. This video is on our website as well. If you ever want to review it, it's there for the viewing. And we'll just get started with that as a first introduction.
Sound Pro millimeter wave meter is the first consumer level 5G millimeter wave meter. This meter measures high band 5G signals between 24 to 40 gigahertz and comes with multiple accessory options for more detailed readings. These options include a horn antenna, a stub antenna, and an attenuator for various uses. To start the unit, press and hold the power button. After that, your battery level will appear on the screen. The mode and max reset button will allow you to capture your maximum values of RF exposure. Now you can attach your desired antenna. To start, we will be using the stub antenna. The stub antenna is ideal for most uses. It has about 50 degrees of coverage in the front and back. It is suggested to slowly move the meter around in a figure-8 motion while in use. The horn antenna is great for more directional measurements. It has about 35 degrees of coverage in the front. Finally, the attenuator is ideal for when your RF readings are maxing out the device. If this happens and the attenuator is not installed, the meter will display a brief message and automatically shut off. When the attenuator is attached, it will display the readings as 100 times weaker, so you are able to measure at higher power levels. When measuring RF sources using the attenuator, ensure you multiply the value by 100 to attain the correct reading. Overall, the Safe and Sound Pro millimeter wave meter is the perfect partner to the Safe and Sound Pro 2, our low and mid-band 5G meter. For more information on the new Safe and Sound Pro millimeter wave meter, the Safe and Sound Pro 2, and other EMF mitigation products, please visit our website at www.safelivingtechnologies.com.
Okay, that was the brief introduction to the meter, and we'll just go through how it operates, some of the screens, some of the challenges we faced creating this meter, and some of the specifications of the meter. So first, the challenges in building this meter. So we've been at it for probably over 8 months of development, and the release date was a few weeks ago, June 30th, 2023. We apologize for the delays. I know there has been several, and I'll try to explain what caused those delays in the next few statements here. So, getting a stable response required additional R&D to get down to the desired building biology specifications. We wanted to see something less than 1 microwatt per square meter. and it took a lot of work to get down there. So we didn't want to compromise on specifications or cost or pricing on this device. And some of the challenges were the power usage. Anytime you measure this high frequency RF, it takes a lot more energy to broadcast the signal and analyze the signal as well. So there's difficulty getting long battery life, but we managed to get approximately 6 hours of battery life out of this with the sound on. And antenna development was also challenging too. Getting the right amount of gain and amplification on the antennas was very challenging. And there we have it again, the sensitivity down to 0.5 microwatts per square meter was the biggest challenge for us, I would say. We know other companies that have tried and not succeeded after a few years of development. So we sympathize with them and understand the challenges they went through as we went through them as well. Parts are very expensive. They're hard to source. Any electronics in these times after COVID are very difficult to reliably secure. So there's all sorts of challenges with sourcing our parts. And then we found third-party testing facilities. They didn't have the adequate equipment to test to our needs, and they didn't have the testing methodology either. So we were kind of between a rock and a hard place here, which I'm sure all other companies were as well. So what we decided to do is purchase our own signal generators and power meters, spectrum analyzers from 1 megahertz to 40 gig, and construct our own full anechoic chamber. So we're able to test around 700 megahertz to infinity for wavelength or frequency in this chamber. So ceilings, walls, and floors have these anechoic tiles on them. Unlike a lot of industrial testing chambers, which don't have the floor covered. So we think this is a very high quality facility and are very proud of it. So this is where we did our development, and any changes we made, we could go right into the chamber right off the bat and change them right away and test the results. So it was a big advantage to us in cutting down the development time. And 8 months seems like a long time, but for a meter like this, it really isn't. So more about the Safe and Sound Pro mmWave meter. We have a base model and we have a horn option. And the frequency range of the base model is 20 gigahertz to 40 gigahertz. And it's a high band 5G RF meter. That's what it's designed for. It'll measure anything in that band though. And the reason why I have the 20 highlighted is because originally we had marked 24 to 40 gigahertz, but through further development, we got that down to 20 gigahertz with the stub or base model horn stub model antenna. So what advantage does this have for us? Well, the USA covers basically 28 to 39 gigahertz of 5 millimeter bands. So this is live in major cities. Verizon Wireless, AT&T, T-Mobile, and Dish broadcast these signals currently primarily in major cities across the US. The Canadian coverage, we're looking at 26 gig, 28 gig, and around 38 gig. And this spectrum is going to be auctioned off in 2024. We have found sources at this period of time, which we kind of were surprised at, and we'll get into a little bit more later on. They're called millimeter waves because of their wavelength. They're under a centimeter basically, and the industry calls this service ultra wide. You'll see the symbols UW or 5G plus on your phone when you're connected to these specific services. And the base model, the cost is $849 US, and we did release this June 30th of this year, just a few weeks ago, and they are in stock and they are ready to go. We've caught up with our back orders now at this point. Here's a link that takes you directly to that page. This document will be published as a PDF on our website just after the webinar is completed. So features. It detects and measures 5G in the high millimeter wave band, 20 to 40 gigahertz. Some of the common sources are, of course, 5G high band cell towers, 5G high band cell phones, radar, some automobile radar, and point-to-point dish communication systems, and others as well. So it's built in North America. It's consumer level, easy to use, very friendly to the user. It's accurate, it's affordable, it's a fraction of the cost of high band detectors. And it is what it is. It is not a replacement for Rhodes and Schwartz, spectrum analyzers or Keysight power meters and things like that that are high-end industry devices. It is a meter that's going to help us detect sources of high band 5G out there. It's going to allow us to assess our exposure, and it's going to allow us to do some shielding as well, and review the results before and after. So that's what this meter is all about, and it displays in microwatts per square meter and volts per meter. You can do peak and average readings as well, and it also has a peak hold feature. The response time is about 50 microseconds or less, and battery life around 6 hours with sound on. So there is an audio feature as well. And just like our Safe and Sound Pro 2, each source has its own unique sound. And we're currently discovering those sounds in the millimeter wave band. And there's 3 sound levels on this device. So low, medium, and high to try and suit your needs. And you can also turn the sound off as well. It also has LED indicators like our other Safe and Sound meters, like the Classic and the Pro. Basically, the LEDs correspond to various levels, as you can see on the screen here, and it gives you a quick indication of your exposure. So basically, if you look at the meter and you see green or green flashing, you're in a slight area or a good area. And if it's red or red flashing, then you're in an extreme area. So just a quick visual on the colored LEDs and how it can allow you to do a quick diagnosis of the environment without looking at the numbers. Another important thing about the meter and any meter, especially with building biology, is the antenna reception pattern. So as we look at the horn, it's a directional antenna, and it has about 35 degrees beam width that it gathers from the front only. So it's left, right, up and down 35 degrees. It will grab that signal. Picture it like a cone going out there, like an ice cream cone, grabbing those signals 35 degree within a 35 degree angle. Then we have the stub antenna, or it's called a semi-omnidirectional antenna. It has 50 degrees to the front and to the back, and left, right, up, and down. So it kind of looks something like this. That's kind of the pattern you're going to see as a reception pattern. And it also receives some from the sides as well. We call those side lobes. And it will gather some information from the side, but it will be most effective directly in front of the antenna and directly behind the antenna. So to cover all angles, we're going to have to rotate this meter in order to do that. And just by looking at these 2 pictures, you can see that the stub will yield higher readings than the horn, simply because the horn is only pointed in one direction, whereas the stub antenna will gather signals from more than one direction. So some of the specifications, so the stub antenna, it is a semi-omnidirectional antenna, which we looked at the reception pattern in the previous slide. Its frequency response is plus or minus 5 dB from 20 gigahertz to 40 gigahertz, and it is effective down to about 18 gigahertz with reduced tolerance, and below that, it kind of falls off on us. So the minimum measurable signal is 5 microwatts per square meter with this semi-omnidirectional antenna, and the maximum measurable is 500,000 microwatts per square meter. Or when you stick the attenuator on it, you can get up to 50 million microwatts per square meter, which is up into the thermal levels if we choose to go that far. The best reception is to have the SLT logo on the stub facing the source and the blank side facing the user. So there is a logo on this antenna, and basically face it away from you towards the source for the best reception. The horn antenna is directional. Here is its reception pattern or frequency response curve. And for it, We have plus and minus 6 dB from 25 gig to 40 gig. And the bonus with this one, it's 10 times more sensitive. It can get down to 0.5 microwatts per square meter, which is great for building biology measurements. The maximum measurable signal, though, is 30,000 microwatts per square meter, or with the attenuator, we can get up to 3 million microwatts per square meter. So it has quite a good dynamic range, especially when you use the attenuator in there. And it should be suitable for pretty well all of our building biology needs and other needs. The antennas were customized for SLT, developed by our RF engineers and our RF technicians, David and Bruce. So yeah, we're very happy with the performance of these antennas at this point. Talking about the attenuator, it's a minus 20 dB or 100 times signal reducer. That's the way to look at it. So if you get a really high signal, it will reduce it for us and allow the meter to give us the proper reading. And you would attach that between the antenna and the meter. And basically you would multiply the readings on the display by 100 if you have this device attached in between the meter and the antenna. Whether it's with the horn or whether it's with the stub antenna, it's compatible with both. And it just allows the meter to display higher power densities by a factor of 100. So that increases the range, as we spoke of before in a previous slide, up to 50 million with the stub and 3 million with the directional horn antenna with the attenuators. So one thing to know about measuring signal strength, there is a built-in overload protection in this device. It is unlike the Safe and Sound Pro 2, which we don't have to worry about overload at this point. So, but it is built into this meter to protect the highly sensitive RF circuitry built in the meter. So this RF detector chip in the circuitry is susceptible to damage if it is exposed to continuous high levels of RF. But overload protection is activated when the following power densities are exceeded. So if the stub goes above 500,000 microwatts per square meter sustained for longer than 3 seconds, and the horn antenna goes above 30,000 microwatts per square meter sustained for longer than 3 seconds. So the meter will power down after 3 seconds of elevated exposures to either of these with either antenna on, and it'll display a warning message. So maximum power level reached, and simply it'll turn off the meter, but to read these higher power density levels, simply install the attenuator and then multiply your readings by 100, and you'll get the readings you're looking for in high exposure environments. So what do you see when you start up the meter and the screens of the meter? So here's the basic first startup screen. You'll see a self-calibration come up. It'll display the battery life. And if you plug this into a USB power and a power adapter into the wall, it'll say, instead of battery here, it'll say USB, and then you can continually run this. It won't run out of power as long as it's plugged in. It'll continually run and monitor for you if you wish. So more on the operation. So the second screen you will see once it passes the calibration screen is select your antenna type. And you would do that via the mode switches, which is right here. This is the mode switch. And you would press the mode switch once to toggle the antenna from horn to stub and vice versa. So pressing the mode button either selects the stub or the horn antenna. And once you have your desired selection there, simply hold down the mode switch for 3 seconds. And that will select and set the desired antenna for you. So next, we're looking at the types of measurements we can do with this meter. So we can measure peak. There's a max peak, which is the highest level that the meter has recorded since the meter has been turned on or reset. And then we have our average levels as well too. So these 3 readings are displayed on the LCD display. We also have a headphone jack. It's 3.5 millimeters. If you plug a headset into this, it will disable the onboard speaker automatically, and you can listen in private through the headphone jack. Then we have the speaker power button. So it has 3 sound levels. Basically, once the meter is on, you would just tap this button and cycle through your different sound levels and set your desired sound. And then we have the USB continuous power port here. We also have a mode switch to select antennas, as you saw, and it's also a max reset button. And if you hold it for a period of time, it will change the units of measurement from microwatts per square meter to volts per meter. Typically in North America, we like to see microwatts per square meter. In Europe, they're more happy to see volts per meter. So we've included both of those measurement settings in there, or both of those units of measurements in there. Future meters, future ideas that we have, some possible options is to combine our Safe and Sound Pro 2 with this meter, and then you'll have a meter that covers 200 megahertz to 8 gig, as well as 20 to 40 gigs. So that may be an option in the future, or just simply designing a meter that goes from 8 gig to 20 gig, or 40 gig to 60 gig, and that includes the 60 gig high band Wi-Fi, which they're out and they're planning at this point. And also have a meter going from 60 to 90 gig. You know, a lot of the new car radar is about 75 gig. So that would be helpful with that. So those are some of our thoughts, and you know, we're always open to your suggestions on this as well. And I'd just like to sum it up right now and thank you for attending this session today. Yeah, lots more good information to come. But I'd like to also thank all of our beta testers out there who helped develop this meter, our engineers as well. And I'd like to thank you for considering adding this meter to your EMF toolkit, because we think it's a great option for you. And we're very proud of it as well. So thank you. And that ends my part of the presentation. I'll pass it over to Tony to introduce Bruce.
You're muted.
That's good. Sorry, safelivingtechnologies.com is a website. All these presentations will be up, including the slides, including the video as well. And that'll probably be up by tomorrow sometime. Bruce is next. Bruce is going to do a short presentation on, again, development of the meter and some challenges and more insight on millimeter wave. Go ahead, Bruce.
Okay. Hello, everyone. Just to check, Tony, you're hearing audio okay and picture is good? Okay. Hello to everyone. It's kind of emotional, actually, for me to see this product, Rob's presentation of it, and to see it going out in the real world. It's been quite a challenge. Rob touched on this. When we first started, we thought this was going to be a relatively predictable evolution from the Safe and Sound Pro 2 meter. And I have lots of experience in other things that I do with 10 gigahertz centimeter wave bands. And I thought I had a fairly good idea of what to expect with millimeter wave bands, but we ran into a number of roadblocks, and can certainly see why there are other companies that had problems in developing this meter. Part of the thing is balancing performance with cost effectiveness. You know, I'm a perfectionist. I'd like to see test equipment have beautiful specifications out there, but fact is the majority of the people that are watching this are not going to be able to afford $15,000 or $20,000 for a meter. And so there is this constant balancing act. So the first thing we ran into was the test facilities. Here in Canada, we had to drive a great distance to go to a chamber that could do stuff over 18 gigahertz, but their equipment was limited. And those chambers are primarily designed for high-level EMI, EMC testing. So in other words, subjecting consumer electronics to high levels of RF. And so they're not really up on the procedures for how to test highly sensitive meters. And so essentially, you know, I think we lost many months of time with poor data from another chamber when we finally realized that it would be great to have our own facility. And one thing that Rob didn't mention, and a benefit of to having our own equipment in its own facility, is that the countless times that I was awake between 2:30 in the morning, I would wake up and think, oh, you know, I wonder if we could do something like this to improve this, or what was causing it when we were in development. So I could go into the chamber wearing my pajamas and made testing a lot faster. And going to a commercial test facility for $2,000 a day for somebody else, I guess is possible, but you'd get some strange looks in your pajamas. But there were many nights, I can assure you, where myself and other people, David, were up long hours figuring out problems. So the other thing was the cost of millimeter wave parts. For example, when you look at the cost of a horn antenna, this is a lab calibrated horn antenna. Look at how small this is. Okay, this has roughly about 20 dB of gain, and it covers 18 to 40 gigahertz. This is a calibrated antenna, $4,200 US for this antenna. Okay, now again, look at the size of this, and you think, oh man, this is a small little piece of tin, and it's like, well, how can it be so expensive? Well, it's precision. Tolerances with millimeter wave stuff are extremely tight, and that was a challenge that we faced with circuit board manufacturing, soldering. So even right now, we're just looking at quality control on the consistency of the millimeter wave components of the meter. Is that if there is poor quality soldering, or if the traces aren't exactly etched properly, or if there's variations in what's called the substrate, the material used where all the parts are on, that has a huge impact. To give you an example, our specification, this is the lid from the safe millimeter wave meter. Our RF test result changed just by putting on this new vinyl label. Why did it change? Well, because the ink that's involved in making this blue and white text color, that ink is semiconductive. And so with the stub antenna sitting here and RF approaching this meter from different angles, believe it or not, this label affected things to a large extent. So does the case. So there's so many things that I thought we would be able to predict, but the fact is we couldn't predict. And again, Rob apologized for the timeline delays, but considering, the problems that we solved. To give you an example of size and scale, this is a horn antenna that's used for testing up to 18 gigahertz. It has about 10 dB of gain. So again, this is going to 40 gigahertz, and it has twice as much gain. Very expensive calibrated antenna. The connector that's used on the top of the meter looks like an SMA connector, but in fact, this is a K connector that's specified and tested to 40 gigahertz. If any tech people go on Mauser or DigiKey and want to look up the cost of a K connector, 2.92 millimeter, you maybe start to appreciate why things are so expensive. So anyway, it sounds like I'm maybe crying a little bit about the amount of time, but the delays to arrive at this specification are actually exceeding my expectations right now, and I'm super stoked to see this out there getting used. And right now I'm back and forth into the chamber behind me, constantly doing things, and of course building more of these meters. And I was just thinking, when Rob mentioned the units of volts per meter in Europe and microwatts per square meter in North America, I was thinking we can be grateful that we at least around the world we're on the metric system, because we could be going with volts per square yard or microwatts per square yard as well. And so at least we're not having to deal with that. So with that, thank you again, everyone that's watching, and to the people that are going to be using this product. It's really great to see this out, and we'll keep forging ahead. Okay, back to you, Tony.
Great, thank you, Bruce. So next is our star tester, Oram. who was out yesterday with Mitch. So we got all kinds of new video and stuff. So I'll hand it over to Oram.
All right. Thank you, Tony. Thank you, Bruce, and Rob for inventing this wonderful meter. Let me begin my presentation here. So this piggybacks on the presentation I gave on June 28th, which you can link to, well, you can see it in the replay of that first learning session over 2 hours. And then this is going to be quite dense with material, so you might want to come back and even review this one in a replay of this session, even if you're with us live, or if you're coming in for the replay, you might want to watch it more than once. Also, a standalone version, PDF version of these slides, just like the first time, will be available. I'm 3/4 of the way through it. There's a lot to do to get that ready, because I have to provide links for the videos to my to the videos themselves. So you won't be getting the videos, you'll get links. Anyway, that will be available tonight or first thing tomorrow morning. Okay, so this is session 2. And just a recap here, this contains videos and still photos from, actually no still photos, just all videos from further field use of the Safe and Sound mmWave 5G meter from SLT that I conducted over the last 2 weeks in Santa Monica, California, near where I live. This covers testing done just in the last 2 weeks, as I mentioned. Most mmWave antennas that I found were on busy boulevards. There was only one that was in a residential area. It appears that they're exclusively Verizon, at least the ones that I measured in the last 2 weeks. And then I also did see some 4G LTE and Verizon low band 5G antennas. As Mitch pointed out when we worked together 2 days ago, Mitch Marchand, who is a building biologist and electrical engineer based in Calgary, Alberta, Canada, who happened to fly down on Monday morning in order to work for these 3 days with a client. Let's see. Oh shoot. How am I going to let this person in? I have to stop screen sharing. Sorry. Oh, what happened to my mouse? There we go. Oh, that's very interesting. Hold on a second, everyone. There we go. I can let that person in. So back to the presentation here. All right. And so Mitch came down coincidentally this week to work with a client for several days, and he'll watch this replay. But he had Monday afternoon available, and I said, what do you want to do in Los Angeles? He said, I want to go around and look at 5G meters, 5G antennas, because they don't have them yet in Canada. So we had a great time, as you'll see. And we do all of us look forward to input from others of you who are getting this meter and will be doing your own testing in the United States and Canada when you get 5G coverage, and also in other countries around the world. So let's get right to these videos. So this is the one on the left will show additional Verizon millimeter wave antenna coverage from this one right here, and also strength reduction as I rotate it in place. So here we go. It's now the 5th of July, 2023, and I'm standing on the corner of San Vicente Boulevard and 26th Street in West Los Angeles. And we have a 5G antenna here from Verizon, and I know that because the UW icon appears, the letters U and W appear next to my phone, or next to the 5G on my Verizon 5G iPhone. And we now have readings in the neighborhood of 976 microwatts per meter squared max, 588 in the real time. Let me see, I'll clear it and then wave it around. And you're supposed to hold it in this orientation, and we'll look again. 884 microwatts per meter squared, and I have the stub antenna in place. And now we're up to 1040 microwatts per meter squared, and you can hear the sound. I'll turn it up, and we're going to turn in place. And you can watch it. Now I'm shielding the signal with my body, so it's down below 100 microwatts. I will reset it. And now as I come around on the other side, it picks up again. because the antenna is out of the shadow of my body, we're back up to 1200 microwatts per meter squared with the stub antenna. All right. So, all right. So now we're going to see how the signals diminish as I move to the right and within the full width of the cone pattern coming out of this antenna right here. My Verizon iPhone is in airplane mode. So the reading that we're getting here is not from my phone, it's from the antenna, the millimeter wave antenna there. And we're measuring around 900 to 1,000 microwatts per meter squared. Now I wanted to show you that as I move to the right and get to the perimeter or to the side of the zones that are broadcasting out of this antenna, it's going 600, 300, 200 microwatts per meter squared. I'm reading it to you from my in meter, and now I'm getting 50 to 70 to 140 microwatts, and I am behind these tree leaves, but I'm also to the side of the antenna. And now I cross this street and I'm further away, so let's see what the reading is there now. Now, as you can see, I've crossed the eastbound side of San Vicente Boulevard. I was standing just to the right of that tree taking the earlier videos, and now the readings that I'm getting on the meter, let me get in the shade here so that I can focus on this, is in the neighborhood of 1 to 200 microwatts. Let me clear that. That's what I'm getting now. Wave this around. This is the distance that I am. I'm literally just across a wide boulevard, and I'm getting in the neighborhood of 300-400 microwatts. But I was getting over 1,000 standing just under that tree. All right, and again, this shows the. Now, as you can see, I am across the street, and we have a reading that is in the 300 microwatt range. I'll clear it, and I'm going to walk this way, away from the antenna, which is over my right shoulder, and get out of the sun here so I can show you what the reading is. Well, we're well below 100 microwatts now. Let me turn and face the antenna, which is actually behind a tree. So there's a tree in the direct line of sight between this meter and the millimeter wave antenna, which is behind that tree. And what I'm getting right now is, you can see, 70 max, and I'm clearing it, and it's going in and out of -5, which is basically nothing as reported by this meter, and 10 microwatts. So the tree, I think, makes a difference in what the reading shows. The next video will show how I found these locations with the signals. So what I've been doing is holding the phone out the window with my left hand with an earphone in place and listening as I drive up and down the streets here, only finding millimeter wave antennas on the busy streets, as you see here, not in the residential neighborhoods. So we have less than 5 microwatts per meter squared where I'm sitting now, but I'm going to drive 2 blocks to the millimeter wave antenna, which is just a couple of blocks in front of me, and show you what that looks like. Okay, and here it is. Now I'm at the corner of San Vicente Boulevard and 19th Street, and we have a 4G installation on the left, a taller one in brown that I'm familiar with because I have a client very near here who hired me because that had just been put in. That was years ago. But to the right, you see a millimeter wave antenna that's new. It's not Verizon. I'll explain that in a moment. But we have, now when I bring this up, this millimeter wave meter, and you can see it's 180 microwatts per meter squared. When I lay it like this, wave it around, this is the orientation to hold it in. Let me clear it and do this again. Up to 200 microwatts per meter squared with the stub antenna. And you can hear the characteristic sound. This is now the 4G antenna is producing up to 10,000 microwatts per meter squared. on the Safe and Sound Pro 2 meter, and that's a 4G LTE meter, or I should say antenna. One of the elements is pointing westbound or eastbound on Center Vicente Boulevard to my left, and that's what we're picking up. So now we'll get a little closer. So we're in front of this 5G millimeter antenna now, and we're getting maximum of about 30 to 40 microwatts per meter squared. Right there. I'm moving this way now. One of those elements is pointing at me, but I'm right behind a tree. I just dropped behind a tree, and look what happened to that number. You see the tree is blocking the millimeter wave signal. Now I'm moving out in front of it. You heard the sound just went up again. A little closer, and it's now above 400. Interesting. And also, you heard that go up when a car went by. Here's why. I wanted to point out here again that there is no 5G millimeter wave antenna in the blocks immediately close to where I am here on this portion of San Vicente Boulevard. And the meter read less than 5 microwatts per meter squared. Until a car, as I'm sitting waiting here to cross San Vicente and go down that street there into the residential neighborhood, but as a car drove by me, it went up to 87 microwatts per meter squared from a car, from a Verizon phone in one of the cars. Well, that's what I thought, and it still may be the case, but what Mitch reminded me on Monday, 2 days ago, is that that's probably radar. He's not measuring any millimeter wave cellular service yet in Canada, but he is measuring 5G millimeter wave activity from radar in cars. And we have other beta testers who have reported the same thing, Eric Windheim up in Sacramento, California, and others. Now I'm right in front of this 5G millimeter wave antenna, and I'm getting in the neighborhood of 1100 microwatts per meter squared at this distance with the stub antenna, and I'll put the horn antenna on now. And now with the horn antenna, we have in the neighborhood of 360 microwatts per meter squared. I'll clear it, and pointing this right at that antenna element. That's about what we get, 350 microwatts per meter squared. But as I showed last time, the width of that cone is much shorter, or much narrower than with the stub antenna. Here's a close-up view of this 5G millimeter wave and 4G antenna array on the corner of 19th Street and San Vicente Boulevard in Los Angeles. And you can see the cabling going to the 5G millimeter wave elements and the 4G at the very top. What's interesting is this is a Verizon installation after all, which surprises me because my phone, which is currently in airplane mode, still says that it's just LTE. I'm not reading the 5G low band or UW, so I'm puzzled by that. But in any event, this is what it looks like. That mystery gets solved a little later in this presentation. And here is this mystery again, standing in front of this antenna. I don't know if you can hear that, but my Verizon phone has been turned on, and we're measuring over 500,000 microwatts per meter squared. On the phone. And it has a very high-pitched sound that's different than the ticking. It comes and goes. So I just wanted to try and show that phenomenon to you. But what is puzzling to me is I do not see the UW or even the 5G moniker on my Verizon phone here. So it's very puzzling. Anyway, just wanted to report that. So that mystery gets solved, as you'll see. So I'm roughly one house lot away from the millimeter wave antenna, and we have in the vicinity of 500 microwatts per meter squared. You hear that? And we're still getting 400 to 500 microwatts. So I'll move back and see how far this goes. So now I still have a direct view of the 5G millimeter wave antenna. One of those elements is pointing right at me, and we're getting numbers that are in the neighborhood of sunlight here, 250 microwatts. Now the minute I turn my body with this stub antenna, I'm completely blocking the signal, and then the top number went below 5 microwatts, which means this meter is not picking it up. But I'll clear it, and I'll turn, and you can hear the sound come back, and now I'm reading 220 microwatts meters squared. Now I'm about 4 houses away from the millimeter wave antenna there, and the meter is reading 30 to 40 microwatts per meter squared at this distance. And finally, now I'm 5 houses away, although there's a lot of foliage blocking the antenna now, but the meter is showing only, well, nothing, less than 5 microwatts per meter squared. And now 5 houses away from the antenna, but again, there is foliage blocking that antenna on that silver pole. So there is a substantial drop-off of the millimeter wave signal with distance and with foliage. I wanted to point out here again that there is no 5G millimeter wave antenna in the blocks immediately close to where I am here on this portion of San Vicente Boulevard, and the meter read less than 5 microwatts per meter squared until a car, as I'm sitting waiting here to cross San Vicente and go down that street there into the residential neighborhood, but as a car drove by me, it went up to 87 microwatts per meter squared from a car, from a Verizon phone in one of the cars. And I showed that earlier, but that's probably primarily from radar. So here we are in a residential neighborhood in Santa Monica, California, at the corner of 21st Place and Carlisle Avenue. And on my Verizon iPhone with 5G enabled, I see the moniker 5G, no UW, no LTE, just 5G. So what would you expect to see on your meters with that configuration on a Verizon phone? I'm going to keep moving here, but think about that and maybe come back and review these slides. And you know, it's a question to help you learn if you're in the United States, how this works. So my analysis of that particular piece of data would suggest that I should see some activity on the Safe and Sound Pro 2. Let me turn on the volume. And there it is. So what does that remind you of? And let me clear it. The sound. Put it out the window and wave it around as we customarily do. There we go. We have 13,800 microwatts per meter squared. Somewhere in this range up to 8 gigahertz. But the millimeter wave meter only shows this, less than 5 microwatts. In other words, there's no activity from this antenna up here. So how does that correlate with the fact that we see 5G on my Verizon phone, no UW and no LTE? What does that all mean? So here's my analysis of that. So my analysis is that this is probably a Verizon antenna in the low band, 5G. Because the 5G shows up on my phone, but it's definitely transmitting in the low or mid band because it's showing up here with all the noise and the number, okay? And it's definitely not a millimeter wave antenna because the UW doesn't show up, and also there's no activity on the millimeter wave meter. And I don't believe that it's a C-band antenna because that would trigger the UW designation next to the 5G. So I think it's just a low band 5G transmitter, which is repurposing of the 850 megahertz 4G signal or frequencies that Verizon has been using for more than a decade. All right, moving on. So the people in these houses are getting a few hundred to 1,000 microwatts per meter squared from the 5G antenna. So that's due to the one 5G millimeter wave antenna that I saw in the residential neighborhood here. So you'll see that in just a moment. So as we saw before, I'm about 4 houses away from 19th Street, or from Alta Avenue, where that antenna is, and now I'm below 5 microwatts per meter squared, and it will start rising as I go to the third house here. No, not yet. Here we go. Now we're getting a little bit, literally no more than about 16 microwatts. You can hear the activity. On 2 houses away, you can begin to see the antenna there pointing down the street towards me. Now I'm getting 100 or so microwatts. And it's starting to get louder, and I'm just 2 houses away. Now it's 200 microwatts per meter squared. So that's the range. You'll see that antenna in just a moment, or a little bit. So my conclusion in driving up and down streets here in about 40 square city blocks in residential Santa Monica, California, I have only seen 1 millimeter wave antenna. Otherwise, this is pretty much what I've seen, with no sound in my ear piece, showing any evidence of 5G activity from antennas. I have passed a couple of cars that had cell phones that were active. The only example was one that I showed you just now. There were 3 total antennas, all of which had 4G or low band 5G. I think these are old 4G installations that have been here for years. I've seen some of them as I've come to clients in these neighborhoods. But the millimeter wave antenna that I just showed you is new. Other than that, most of this residential neighborhood is devoid of a millimeter wave 5G antenna. So now we're going to see videos with Mitch.
So I'll just go in. So these are our baselines without downloading anything. So Oram's just going to hit the go button there.
Antenna's here.
And we're just going to wait for it to kick in to ultra wideband. Okay, now we're going to move the meters away. And it's pretty far. That beam is quite large.
Yes, it is. It's still 31,000 over here.
Yeah. And this is the upload. A little bit less, but that's kind of what we were seeing before.
Right.
But that beam is
Quite wide.
quite wide. I'm assuming.
Yes.
Yeah.
Okay. All right. Sorry, let's play this one here. Okay, so we're cleared again, and we're down to relatively low levels. So we're going to activate then the 5G. Go ahead. And you can hear it there. All right.
We start walking away here. Going halfway through the speed test.
What's the top number? Go down.
Okay, that's the end of the download. Now it's the upload.
Of course, I'm behind a tree, unfortunately. but still, it did peter off. It actually stayed high until I
Do you want to go to the corner?
Yeah.
And I'll give you a nod when.
Okay, so I'm far away now. There's Mitch over there. Okay, tell me when you hit go. Yeah, I heard it here. Mitch has my cell phone. But it's not very strong, but I can hear it. It just went off. So Mitch is triggering or turning on an app on my cell phone to just get some data usage, which triggers this beam-formed signal, and we'll talk more about that. Okay, so now Mitch and I have switched places, and he's down there where I was, and I'm here, and we have relatively, you can hear the activity, but it's relatively low. Okay, go ahead. So he just activated there. So he's over there. How much are you getting? So Mitch was getting 6,000 microwatts over there where my phone is that's activating this antenna or doing the download, and we didn't go above 144 over here.
Okay, so something we just realized was we were actually pegging the meter. When it shows like 30,000 or 31,600, we're actually pegging the 1 meter using the horn antenna. So this,
Both of them actually, before.
yeah, and the stub antenna maxes out at 500,000.
Yes. Which I've seen multiple times.
Yeah, so now we're just gonna set this one up. Oram has his phone. He's gonna hit the go button. And it's connecting, and as soon as there we go.
See the UW?
Yeah, so now we're at 200,000 max. 500.
There it is.
Okay, so it maxed out when you brought it really close.
Yes.
That's
See that number there is changing as I move this close and away.
Yeah, and I pegged it on the horn on this one.
31 from the antenna.
From the antenna, 31,000. So it's very easy to, depending on which one you're using to peg it just with a phone.
Mm-hmm.
So that's the maximum value that these meters can read under these settings.
Well, although that 31,000, could that have been coming, that would have come from this, because we've never gotten 31,000 from the antenna, have we? We were trying to figure this out in real time. It was very interesting. Go ahead.
Yeah, so just a quick way to tell what you have set up is if the average is showing less than 0.5 microwatts per meter squared, you will have the horn set up, and this is just with background levels.
Not just the fact that you have it here, but the setup in here.
The settings, yeah, shows less. The lowest it shows is 0.5, versus when you have the stub set up when you first start up the meter. The lowest the average goes is less than 5 microwatts per meter squared. So that could be a quick check to know what you're setting it at before you start measuring.
Very good. You want to make, okay, so we're trying to figure out what is causing a signal to show up on the RF meter, whether it's the antenna or my phone, because there is a 5G signal coming from both.
So now we're just going to look at, we have 2 mmWave with the horn antennas. And one's going to be measuring what's coming from the antenna. The other one's going to be measuring what's coming from the phone. So Oram's going to hit the go button on the speed test. And what we'll see is...
And it goes from 5G to, when this kicks on, you'll see the UW appear. It's just an app. Any app will do this. There we go.
So about 31,000 on the top one, about 2,000, 4,000, 7,000, depending how we hold it. 7,000.
Look at that speed.
And there's no change in the sound for the upload or download. Yeah, the upload seems to be a little bit less of a, and now we're just back down to, now the speed test is done. But we went up to about 1,000 on the upload. I'm not sure if that was just how I was holding the meters, but it was 7,000 on the download on this upper one. So it seemed to be a little bit less on the upload. But this one stayed about the same regardless, stayed about the 31,000.
Coming from the phone?
From the phone.
Okay.
Yeah. So now we're just going to set the phone's got a set distance away. I'm going to say that's about a foot.
Yeah.
A foot away from the phone.
You ready?
And let's hit go. As soon as it makes the connection here. Okay, so I'm just going to... Yeah, so I'm at 11,000, 31,000. So I pegged the horn antenna.
Interesting.
Yeah.
And this is 71,000.
71,000, yeah.
Here's our analysis of that.
Okay, we're gonna do it a little further away. Yeah, do it that way. I'm just gonna show the baseline numbers, and then Oram's gonna hit go. We hear the sounds. I'm just gonna have a look. I'm gonna tilt the meters. We'll have to look at the video when we're done. Now we're doing the upload. And it's complete.
And that sound over there was More analysis. So you want to summarize what you said about the beam, the signal coming from that with.
Yeah, it appears when we're using the horn antenna pointed at the, we were probably 3 feet away from the phone, and we were still pegging this at 31,600.
Right.
So that tends to lend itself that when that signal is coming from, when it's beamformed from there, it's fairly significant. Like it's 31,000 still at 3 feet away from the phone. So, and that's basically what the antenna is pitching towards the phone.
But more than 31,000.
More than, yeah, we don't know what it is.
Right, exactly.
Yeah, so it's significant, right? So that.
Well, we actually do have an idea from the stub antenna here, even though it's turned the other way around. We got what, 70,000 on that?
Yep.
Yes.
Yeah.
So that does tell us what's coming from the.
Yeah. So there's at least 40,000, right? 70,000 minus 30,000 is about 40,000 maybe
Right.
coming from there.
Yes.
Maybe.
Because
So-
my phone was several feet behind these meters this time.
Yeah, it's 3 feet away.
Right.
I would say at least. Yeah.
Yeah. Okay. And later, after we did this, we realized we could have used the attenuator. So that's coming up.
Another summary.
Yeah, go ahead.
Yeah, so it seems like what we found here is there is kind of a 24/7 background level coming from those millimeter wave antennas, and it's measurable anywhere nearby. Then there is when a phone gets activated to do a significant download or upload, the phone begins the transmission, a beamform, I'm assuming, from the antenna to the phone, and it tends to spotlight or have a cone of increasing exposure that's quite significant.
Along the entire length of that cone.
Yeah,
From
the
the
cone
antenna.
starting at a point at the antenna and spotlighting to where the device is, and probably maybe 3 or 4 feet.
Mhm.
We were seeing elevated readings, but the other significant thing is when that phone is beamformed, or when that signal is beamformed to the phone, it seems like the background levels have a change in sound from the
Mhm.
meter,
Yes.
and a slight increase in exposure overall.
Right.
So what that means if you have 4 or 5 people downloading things, I don't know.
Mm-hmm.
But yeah, that's kind of what we figured out, and yeah.
Okay. And a couple more summaries here. This is,
Well, there's the
there it is. That's
millimeter
wave tower. We're back here at Alta Avenue and 19th Street in Santa Monica. And what do we have here? 800, clear it, 400, 500 microwatts. And we just see LTE here. Now I'm going to turn on, so I just
Internet
started-
radio.
and the 5G UW went on, and now we're getting 23,000. But that's from the phone. You see how look at that top number. Is that right? I'm not on the path of the
some's from the
antenna.
tower, some's from the phone.
Yeah, and it's coming and going. Now let me, let's see, open this up and just open up a website. So any activity here on the data side makes this, turns on the beamformed millimeter wave signal, right?
Yeah, and we noticed when we were iMessaging and texting
That
images, it didn't
did not
really-
happen.
Didn't initiate the
Right.
millimeter
We're not
wave.
even sure with FaceTime, but
Yeah,
but anything to do with data made that happen.
yeah.
So we are considering what the implications are of this kind of a millimeter wave antenna with 4G on top, and what's the implication for the houses around here. So what were your thoughts, Mitch?
Well, I don't know. The house is probably within, I don't know, 100 feet or so maybe, or they're going to have this elevated, maybe adding another 100 microwatts per meter squared.
Of a
To
very
it.
complex signal.
Yeah, a more complex signal, so we have to probably evaluate it a little bit more critically because it is more complex and potentially more biologically annoying.
But when triggered,
Well, just the background level has increased,
yes.
right? About
Yes.
100 microwatts per meter squared.
And then there's another level above that.
And then when it's triggered, even by somebody walking by trying to download something or checking the internet,
Mhm.
right? It's going to increase that background, that 100 microwatts up a little bit more,
Yes.
right?
Coming out of this antenna, because there are a lot of passersby, a lot of people have been walking by here, which is why this is here in a residential area.
Yeah,
And
there's going to be a hot spot, kind of spotlit on the person as they're moving through with their phone.
Right.
If they're accessing the internet, if they're texting or sending a photo over iMessage or something like that, doesn't seem to trigger it. It's if they're accessing the internet through a browser or trying to download a movie or a big file, that's probably what's going to trigger it. And then, so it's going to be a hot spot where they're at, kind of a beamform signal to following their phone, and the other background levels are going to increase incrementally, a small amount.
But for the houses here, that won't be as much of an issue.
I don't suspect inside the house there's going to be a huge fluctuation.
And certainly not behind a stucco wall, and
Yeah, you know,
unless there's a window, as you said.
Yeah, for people with bed canopies, direct line of sight to stuff like this, they'll probably see a measurable, as slight as it might be, maybe 10 microwatts per meter squared, 1 or 2 microwatts per meter squared. Probably they'll see a difference with the millimeter wave in the canopy
because of the holes in the fabric.
Yeah, the millimeter waves will get through kind of quite small holes.
And screen,
Yeah.
Even fine mesh.
Yeah. People, if they use shielding materials such as foil, which is a solid material, probably won't see any difference
or the 2 layers
before or
of
after.
paint.
Yeah, their outdoor environment will see a background level increase, but their inside probably won't if they're using foil.
Okay, thank you. So here are a couple of slides of conclusions, and then we'll take questions. So these are the conclusions. This is a summary of what Mitch just said. Beamform signals are fairly significant in terms of their power density. Hundreds, if not even more, thousands of microwatts per meter squared when that beamform signal is coming in to the device. And then there are 3 separate effects that we found when in proximity to one of these millimeter wave antennas. There's 24/7 background level across the full cone from side to side of 120 degrees from left to right in front of each one of these antennas. Number 2, the cell phone of that carrier and only of that carrier. If you have a T-Mobile phone and you're in front of a Verizon millimeter wave antenna, you will not trigger this beamform activity. Only a Verizon phone will do that if it's a Verizon antenna. If it's a T-Mobile antenna, my Verizon phone will not trigger it. You see how that works? So anyway, the phone of that company triggers the beamform signal with data usage as the spotlight, as he calls it, to the phone or tablet, 3 to 4 feet wide at greater than 31,600 microwatts. That's what we measured. At the same time, the background exposure level across the full cone from side to side also elevates up slightly, perhaps 100 microwatts or so. Again, when the customer accesses data. And finally, there we go. And here are the conclusions that he and I came to based on my analysis and field testing this time and even last time in the last 4 weeks. Beamformed signals are fairly significant from the millimeter wave antenna. And that solves that mystery that I explained earlier or couldn't figure out till I met with Mitch and we realized what was going on. So the beamform signal is triggered by the phone from the same cell carrier. There are 3 separate effects in the proximity that Mitch just mentioned. Millimeter wave antennas are still rare in residential neighborhoods. I only found one in 40 square blocks, whereas there were a couple of other 4G antennas there. And then millimeter wave signal is blocked by solid walls, by a body, by a tree, by foil, by paint. But the signals will not be blocked effectively by glass, fabric, or mesh screen because the signal can pass through the holes in the screen. So let's see. And the recommendations for further testing: use a cell phone from the same carrier, cell carrier as the millimeter wave antenna to trigger the beamform signal when you're doing your testing. Verizon by far predominates in terms of millimeter wave service. They poured all their money into that in 2018, 2019, 2020, and only expanded down into the millimeter wave and even the repurposed 850 low band 5G service just in the last 2 years. We will use an attenuator when measuring with the horn antenna when we're measuring the activity from the beamform signal from one of these antennas, because the signal exceeds 31,000 microwatts. And we do note an increase in the average value, which indicates more density of the RF transmission, meaning less time between pulses. So the discrepancy between the average value and the peak or max peak will be less. There will actually be some activity on the average, indicating that there's a lot of density, a lot of signals in a short amount of time with less space between them. So I think that's all. So let's see here. I'll stop the share and turn it back to you, Tony.
Okay, so now we're going to open the floor up to question and answers. Again, this broadcast will be rebroadcasted on our website as a video for download or viewing, and also these slides and all of Oram's videos and Rob's slides will also be back on our website. And within 24 hours, we should have everything back up if you guys want to replay or have specific segments you want to look at again. So if anyone has any questions, please raise your hands. And
Tony, just some comments
go
after
ahead,
Oram's great presentation there. So just one thing that just grabs me is, you know, the whole design of this millimeter wave system. I mean, for trees to be blocking the signal as they do, I mean, it just seems like such an inefficient way to operate a digital phone system. I don't understand it, but it seems very inefficient, and that's the reason why they have to have multiple transmitters on every block or every second light pole. But these are what Oram has done is these are great observations. We're in learning mode, and just to see all that happen is really good for us, and we just have to be a little cautious on drawing conclusions. We need more testers doing this in more areas to compare all the results together, and that'll help us draw more positive conclusions. And one thing I'm not 100% aware of, if we have a huge transmitter like the cell phone right behind the horn antenna, how much of that RF is going to still register on that horn antenna? So that's one thing that I'm questioning a little bit right now, and we'll have to figure out a method of doing this that eliminates that. And it's pretty tough where you guys were too. You were on a narrow, it seemed like a pretty narrow street with only a couple transmitters on it, so it had to be challenging to do that. You did gain some separation on there, but that's just one thing that that I'm questioning in the back of my mind a little bit. And also there's a great point you made about the average signal. So as building biologists, we always like to look at the peak signal, but the average can give you some good information as well.
Yeah, Mitch, that was quite, never thought of it. Always ignored it on the Safe and Sound Pro 2. And Mitch said, well, wait a minute, it gives you some information here about the density of the signal.
Exactly, yes, because what you're measuring is this beacon signal, which only happens, you know, a few times a second perhaps. But once you start pumping data down in that 1 second, there's going to be much more information, and it's going to raise the average exposure. So this is one thing that, you know, will separate us. You know, it'll give us credibility with industry if we start looking at averages as well. Because it's also an important thing to look at. Once you've got multiple conversations or high amounts of data coming down, we're going to see that average value creep up a bit too. So it's something that we're going to have to pay more attention to, I think.
Thank you, Rob. A couple of points I want to mention, and I just quickly scanned through the chat. Ivo said, direct messaged me, and he said, you have to change lower the shutter speed. I have an iPhone 14, and I've tried. I've gotten feedback from Tyler and others at SLT, and Mitch tried to help me. He has an Android, and the reason why we were able to get shutter-free, flicker-free images was he went in. He has a Pro model on his whatever he has a Galaxy or something. It's an Android, and he for his camera settings, he was able to go into the Pro settings for the camera, and then he adjusted the shutter speed, which is why it was the image was washed out off in the distance, and we never got a good image of the cell of the antenna itself because of the way the light played, but there wasn't that flicker. I'm not able to do that on my iPhone 14, and if anybody knows, I'd love to know how to do that. Secondly, someone asked what app did I use? Any app on your phone that uses data will trigger this response. If it's heavy on activity, like streaming, for instance, would clearly do that. I happen to use speedtest.net. I actually have downloaded that program, and you know, the speeds of 2,300 megabits per second are astounding from that standpoint. So it's like quite an advance, but at a great biological cost. So in any event, I just wanted to answer those 2 points. Laura, you want to unmute yourself from California? Baldati, and please.
Hi,
Welcome.
I bought your Safe and Sound Pro 2 to measure the microwatt. I don't understand what's the difference between the Pro 2 and the new one you put on the market. I have a 5G antenna above my unit. I live in downtown San Diego, and I also had a professional coming in and measure the radio frequency, so they can distinguish the radio frequency from the antenna and my Wi-Fi and whatever. And I had 500,000 microwatt per, I think, square meter. Yeah.
Right.
And on my balcony, and 250,000. So whatever you are showing in your video is so low. I can't find anything so low anywhere in the street. I went down in the street, and the best is 2,000. But anyway, I had to put, you know, the paint, what's called graphite paint, and reduce a little bit. I mean, reduce actually 90%. And now if I turn on my meter, I have 10,000 microwatt per square meter, and I think I cannot go lower than that.
Well, 10,000 is, you know, 90 or 99% of, you know, 1 million or 500,000. Yeah, that's the problem. It's still not a safe level, even though 99% reduction sounds great. 20 decibels of reduction sounds great.
I don't know where to go because even in the street, I was walking down the street, and there's a 5G antenna from AT&T, by the way. And I was walking down in the street, and in some area, I got 600,000.
That you're not okay. I talk about this on my website, createhealthyhomes.com. And then if you click on education, you go into the section with my articles. And in the welcome page there, I have an article on 5G. You might want to go there, createhealthyhomes.com.
Yes.
And go to click on education. And on the welcome page, you'll see a 5G, because I explain that we have low band 5G, mid band 5G, and high band or millimeter wave 5G, which is, and it's that high band above 20 gigahertz that this particular meter that we're all talking about here right now, which it was never available until now, with one that is so well designed and works so well from Safe Living Technologies. It's able to measure from 20 gigahertz and up. And yes, that's exactly right. If those of you who attended the first one and saw, I made a big point about this, that I actually had, you know, the green meter and the blue meter, you know, the Safe and Sound Pro 2, which measures the low and mid band in one, you know, and then the millimeter wave band in front of an antenna that had both elements, that generate the low and mid band 4G. All 4G is in the low and mid band. And then there is some 5G in there as well in the mid band and the low band. So it's very complicated. And then there's 5G in the millimeter wave band, which I've never been able to measure until now. I had another meter for 6 months, and then now this one. And now it's a whole new world for me, because I can actually measure what we've been concerned about for the last 5 years with 5G. But 5G has 3 parts.
Okay, but what's for your health the concern? I mean, in my opinion, the radio frequency.
It's not healthy to live in an apartment right below antennas that are on the roof of a multi-story building, and that's a whole nother conversation. And So what you're primarily picking up is 4G. I assure you of that. If you're picking it up with you can call it mid-band and low-band 5G if you want. I just call it cell signals or 4G/5G. Let's be real about this. You understand? And so we can talk about that some other time. I actually go down to San Diego and work with people if you're interested in connecting with me, or you can call any of us or call Rob up in Toronto at Safe Living Technologies to get more detailed information, or Peter Sirk, who is in San Diego. And it could have been his company that came out to your house, actually. And he's on the call right now.
Yeah, it actually was.
Okay, very good, very good. Well, he's an expert. He's the premier expert on radio frequencies in our profession here in North America and worldwide. So
company came and put and did the reading.
good, very good. Anyway, so we'll continue that, but
when difference between the 2 meter, you buy the meter because you want to be sure you're safe. Okay, so when I have the green meter, and what makes the difference? Why we need another meter to read the difference in the 5G? I mean, they're all harmful for your health.
Well, Rob, you want to speak to that?
Right. Yeah, we want to reduce our exposure to all radio frequency waves. So this blue meter expands on the green meter on what we can now measure. So like Oram said very, very eloquently, it basically measures the high band of 5G. So we don't want high exposures to the low bands or the high bands of 5G. So basically we want both of those meters reading 0 if possible, but that is never possible. And we're also finding that the readings you're going to get with the green meter they seem to be on higher levels than we read on the blue meter at this point too. So that is an interesting observation too. So
but we will say that the millimeter wave signals and this low band stuff, I'm sorry, the low level stuff that Mitch and I saw and that I've seen for several weeks, and you're all going to see, that's new. I mean, that's not expected based on what I was told by the engineers at the 5G trade shows that I've gone to over the years. I really want to talk to them in September at the trade show I'm going to in Las Vegas, the Mobile World Congress conference there in the 3rd week of September, to find out what that is. Now, the turning on of this beamformed signal is exactly what I remember them saying. And it is very high in that one zone. Okay. I don't know what this other stuff is, but it is lower, but it's much more complex. Everything that we've heard all these last 5 years, and even earlier than that, about the difference between the beamformed 5G and then again, the 5G is just a marketing term by the industry to designate any technology that's released in the 2020s. Anything in the 2010s was 4G. Anything in the 2000s was 3G. It's just 5th generation, not to be confused with 5 gigahertz of Wi-Fi, which is also abbreviated 5G. So don't get confused there. So there's a lot of densification of antennas, a lot of modulation of the signal, compressing it, polarizing it, that makes it more biologically harmful than the previous ones, but they're not safe. It's all unsafe. And so the level is complex. So we do have to consider, and we haven't yet, what is the biological effect of these millimeter wave signals that we can now measure with this great little meter. And, you know, but what I'm trying to do, what Rob's trying to do, what Mitch Marchand is trying to do, what Larry Gust, who's with us here, who's also, you know, basically Rob Metzinger, Larry Gust, who's with us from Ventura, California, and Mitch Marchand from Canada are the 3 principal teachers for the building biology profession. I'm an adjunct faculty member as well. And so what we're all trying to do is to help people understand what the technology is, how it works, and what the health effects are, and how prevalent is it really. So anyway, so Laura, let's move on to some other questions if you don't mind.
No problem.
Thank you very much for your, somebody else had their hand up, or you can unmute yourself and ask a question. I know there are lots of questions in the chat, which I haven't been able to pay attention to. But if you want to ask your question verbally, we can answer it. Tony, you're muted if you're speaking to us.
Oram, I wanted to
Yes.
ask you about the rollout. I think people want to know, what is the rollout for high band 5G, especially in the US? Like, what do you know? What states have it? Where is it? Where is it right now? Where is it going?
Okay. Okay. I've been talking about that for 5 years, since 2018, because the shift from one number to the next number, which is 10 years long, is not happening at the first year of the next decade. It's actually happening 2 years earlier. So we shifted from 3G to 4G in about 2008. And we shifted from 4G to 5G in about 2018. And we will shift from 5G to 6G in 5 years, in 2028. We're already talking about 6G now, which is more AI, more processing of and more automation of the processing of data flow, the flow of data at coupled with edge computing really at the level of the transmitters, not at the central office and the phones, the devices themselves. Okay, so to answer your question, Tony, there were 4 major cell phone companies: Verizon, AT&T, Sprint, and T-Mobile. And then 2-3 years ago, the FCC allowed T-Mobile and Sprint to join. And so T-Mobile basically took over Sprint, with the stipulation that a 4th company had to take its place. We still had to have 4 carriers. So Dish is now coming up as the 4th carrier. And Dish is producing an entirely standalone, that's a term, for a 5G network of equipment from the ground up. They don't have to service their 4G customers. Now 4G, and this is all for data, by the way, guys, not for there is 5G VoNR, VoNR, voice over new, NR stands for new radio. But that's lagging, and that's still, but most of the data, 75, 80, 90% of it in most places is still handled by 4G. But 4G is becoming more advanced, more modulated, and having more of an impact on people. So that's to be, and they're dropping in these small cell antennas into residential neighborhoods to take the load off of the macro cell towers that are 1 mile to 1.5 miles apart at lower power densities, but they're always on and they're right next to homes. And so that's the biggest, and it's mostly 4G technology. There's some 5G mixed in, including the C band in the mid band and the low band. But basically 5G has 3 components. It has a repurposing of some of the 4G signals at 600 and 850 megahertz, which is just a little, it's faster, 3, 4, 5 times faster than 4G and more modulated. And that's low band or nationwide 5G. Then there's the mid band 5G, which is more 10 times to 15 times faster. And again, more modulated. And that's 2.5 to 3.5, 4 megabits per second. That's being rolled out. And Verizon has a lot of that now, and AT&T. On T-Mobile, Sprint had all their 5G at 2.5 gigahertz, which was faster, and T-Mobile inherited all that when they acquired Sprint. And then Verizon put all their 5G efforts into their millimeter wave service. And the thing about that is, relative to what you said, Rob, earlier, the millimeter wave signals have such a short wavelength. That's why they're called millimeter waves, or millimeter wave band, because it's only 3 to 5 millimeters. And it doesn't go through walls. The physics of it does not allow it to go through walls. It doesn't go through glass well. You don't need special paint or foil to block millimeter wave signals through a wall. Glass, it's not. It will pass through. We realize now, but walls are pretty. Just regular walls will block it. It's really an outdoor phenomenon as far as the industry is concerned. It's for people who are outside to receive it and get the benefit of literally 100 times faster download speed, as you can see. So there's so much more. I would just say, Tony, that if people want to know more, go to createhealthyhomes.com, click on education, and right there, there's a link to the 5G article that I wrote. So Nancy, you had your hand up.
Hi, thank you, Oram, for your great presentation and your
welcome.
research. There's a number of questions in the chat on how to shield from this 5G, and one of them was, will the film that we use on our windows, will that block it? And you
Well,
also said
Nancy,
no
can I
fabric.
interrupt you? You know,
bet.
I would like everyone who asks that question to say, how can we block cell signals at 4G and 5G? Because 4G predominates. 75 to 80% of what's coming at you from any cell tower is 4G, and it will be that way for another decade or two. 5G is coming along, but this super fast stuff in the millimeter wave band, that's not in residential neighborhoods. The only people who benefit by that are is foot traffic. And there was a lot of foot traffic actually around that one that I showed you. But every other installation that I have seen, that I have presented, that I've seen in the last month that I've had this, have all been on boulevards, commercial areas where there's a lot of foot traffic. Do you understand that? So you're
yes.
really dealing with 4G.
Yes, but I should have clarified for 5G, or not 5G, for for the millimeter waves. Will the film that we use on glass, will that attenuate it? You said that fabric and metal screening won't.
Because it can get through the pores, but solid can. But do you know that you have a millimeter wave antenna in front of your house? That's a good question.
I know I don't. I'm asking for the people that do and are asking in the chat.
Right.
Well,
let me take that, Oram.
Please.
There's not a lot of test data that we have on window film at those higher frequencies. I have seen some, and they seem to perform fairly well consistently along the whole frequency range, all the way from 10 gigahertz all the way to 40 gigahertz. So I'm expecting that it will do fairly well. With a caveat, I'd like to see it and measure it myself before I confirm that. But yeah, it appears to do quite well in that range. But I'd like to see a practical application of that first before I totally commit to that.
And Rob, in my experience, I know what the data shows, in an anechoic chamber and on your website for the window film that you sell, but in the real world, I don't see the reduction that is advertised. And I'm not criticizing, and you know what I'm talking about.
Mhm.
There's reflections, some passes through walls, because the thing about the 4G, the low band and mid band 4G and low band 5G and mid band 5G, the physics of those signals is such that the wavelength is 15 inches at the lowest part of the low band, and then 3 to 5 inches at the upper end in the mid band. So so all of any signal that is transmitted in those in those frequencies that have those wavelengths of 2 or 3 inches to 15 inches will easily pass through walls. Okay. And so we need shielding in order, and the shielding blocks it somewhat. If we're lucky, we get 60 to 70 to 80, 90% reduction. And it all depends on how close the source is and how strong it is in terms of how much reduction you get, how much reflections you have, what you have coming from other directions, and what you have in your own pocket. Everybody's worried about 5G out there, and they're running around with these in your pocket. And they're getting blasted with RF that they're not even aware of if they don't have a meter. You see what I'm saying? So, I have noticed, Rob, that the film doesn't block as well as paint, 2 layers of paint on the wall, for instance, or the foil. I mean, you would agree with me on that?
Right, it's not as dense.
Yeah, in practical
so,
applications.
Yeah, it does have some gaps because it is kind of, the metal particles are sprayed onto the film.
Right.
So there is a possibility that millimeter waves, especially higher frequency millimeter waves, may peek through that. But I'd like to do some more testing on that.
Windows are tough.
Right.
It's a hole in the wall. And if you have an electrically sensitive person, who has radar sweeping around with 50 to 100,000 watts every 6 to 12 seconds, 25 miles out, and you're up on a hill. And you have a big window wall with a sliding glass door. I have clients like that in up in the hills of Malibu or Palos Verdes estates, and we have multiple airports in Los Angeles, and they have this radar sweeping in, and we are supposed to multiply the number on our meters by 10, and that's the actual exposure that we get. So radar through windows is very difficult. Airport radar is very difficult. Anyway,
Good question. We'll probably have more information on that in the coming weeks, I would think.
Rob, if you could also do some testing on like this Swiss Shield, the higher attenuating fabrics for the millimeter frequencies,
Right,
that would be great.
Right, Nancy, that's already been done, and Mitch alluded to that during some of his comments, and it does let higher frequencies through, but we're still looking at 90 to 95% shielding from it at 40 gigahertz, or between 20 and 40 gigahertz. So because it's made out of a grid pattern of wires, small signals will get through, but we're still looking at 90 to 95% attenuation from the Swiss Shield fabric even.
Well, that's great. Is that with the Ultima?
Ultima and Naturel as well. It's slightly less than Ultima, but yeah, the majority of Swiss Shield fabrics are still up there. Not ideal, but they still do a very good job.
But Ultima allows you to ground it, and you have to pay attention to the electric field issues. And then also, the only way you get the reduction that Rob just mentioned, 20 to 40 dB, that means 100 to like 99.99% reduction, is if you literally create a Faraday cage where you have enclosures on the four walls, the top and underneath, and with no gaps.
Right.
You can't apply two layers of white shield paint on one wall and some window film on a window and expect to get that much reduction inside your room. It's a whole different situation.
Those waves bounce around.
Yes, exactly. And they're meant to penetrate. And you look, we all need to appreciate that there's always a mixture. Whenever we hear about 5G in our EMF community postings and websites and podcasts and interviews that people do, I would like, in the same breath, that anyone who says, you got to pay attention to the 5G that's out there, also pay attention to the 4G and the Wi-Fi that's in your house and in your pocket, and understand that most signals are still 4G in terms of cell activity out there. But it's not good, and 4G is not good at all, and it's getting more modulated, and 5G is coming in. That's what everyone's focusing on, but it's really a mix of multiple frequencies, multiple protocols. The industry is looking at the protocols. They're looking at the technologies, and I talk about that in my articles. That's what when I talk to the engineers at these trade shows and listen to their webinars, and a lot of it goes over my head, but I am able to follow a good amount of it. They're talking about all these use cases and the way that the signal is modulated, and we need to determine what are the biological effects of each of those technologies and the way that the signal is shaped by the radio and then transmitted by the antenna. And we're trying to understand that. And that's what we got into in the videos that Mitch and I did 2 days ago with this great new meter.
Oram, are they just going to phase out flip phones, 3G completely? So there's not going to be any safe phones?
I wouldn't consider 3G to be safe or flip phones to be safe.
Well, flip
pick
phones,
your poison.
Well, the flip phone, I've never had a cell phone, so I don't consider any of them safe. But like there was one phone that I recommended to a patient of mine who's EMS, her wife was EMS, and the consumer cellular LG TE, I think, Link 2, when it was turned on, he borrowed my meter, was only 5 microwatts per square meter, and when he used it for a phone call, the highest it went was 4,000. Well, the new smart meters are exceeding the Pro 2's range. They're in the millions.
It has to do with the onboard technology. A flip phone is not, I mean, a smartphone is loaded with apps, downloads, push notifications. There are 6 antennas in one of these. The flip phones are much more simple. We just, you know, what Larry Gust, who's here, and Rob Metzinger and I and Mitch Marchand teach our students is to help them to be hardwired as much as possible for their data, for their texting, for their voice communications, the streaming, their baby monitors, and so on. So there's no such thing as a safe cell phone. You just want to minimize your exposure to it. I hear what you're saying. Yes, 3G is being phased out, and any phone you buy that's less than 10 years old is filled with apps. You can turn a lot of stuff off. You can minimize it. And on my website, I have, in that same, go to education, I have an article, safer use of cell phones. And many other people have written great articles about this as well. So.
Okay. Well, great, Nancy. Thanks for the questions. And Oram, if we could just move on to the next one.
Yes, thank you, Nancy. Lydia, you have your hand up. Unmute yourself, and what's your question?
Yes, hi. Thank you all for just advancing the meters and testing, et cetera, and helping us all be safer. So I'm in Virginia, and I know they're testing 5G. I'm going to speak like a layperson, which I am. Now, I am.
Well, I'm sorry, you said that people are testing 5G on you?
Oh, well, no, they're testing in our area. I remember seeing that in the paper, 5G. I just want to leave it at that for a second and have you deduce a few things. But right now, I am wired in the house, and with the safe and sound basic meter, my light blinks green pretty much all the time. I have a cell phone which I'm using, but then I keep that at a distance. But what I am being impacted by is something I think from skies, i.e. maybe satellites or radar. I don't know what it is. But okay, so the question to you is, are you expecting that we'll be needing to read high frequency or high band, use the blue meter, let's just say, for things from the skies? Right now, I feel, I guess you could say I'm hypersensitive, but I'm sure I feel impacts of what's coming from the sky, and it just kind of moves around.
Okay, Lydia, can I ask you a couple of questions?
Tracks me,
Okay, are you in an urban or a rural area?
I'm in what you probably call a sub-rural one. I'm not in a city proper. I'm in a little town.
Good.
And they are they're testing. This was an area picked as 5G testing. Okay,
well, as far as the industry is concerned, 5G can mean many things. It could mean a low band service. It could mean mid-band service in the C-band or the Citizens Broadcast Radio Service, CBRS. I know I'm throwing terms out that don't mean anything to many of you, but that's what's coming. Or the millimeter wave service. But if you're in a little town, I highly doubt that any of the 3 companies would be investing in the millimeter wave service that you saw me measure in your town, to be honest with you.
Well, put it this way, I can hear what I think is the wide band around, but
well, I'm here in your ears or on your meter?
From my ears. I'm sensitive.
Okay, but how do you know what frequency you're?
I don't know. I do not know at all. It's not.
You need meters. If you want to.
I don't have the millimeter wave meter, but I have the others. I have the R meter.
The R meter. What does that mean?
Mm-hmm. Safe and sound.
Oh, the Pro 2.
Not the Pro 2 and
classic.
Yes, a basic one.
And okay, and it has sound.
3830B.
Oh, okay. Lydia, the building biology profession has a website. It's www.buildingbiologyinstitute.org.
Right.
If you go there, buildingbiologyinstitute.org, and up along the top, it says find an expert. You click on that, then you click on certified consultants, and then you click on either building biology, environmental consultants, or electromagnetic radiation specialists, and you'll see a list of practitioners who Rob and Larry and Mitch Marchand and I have trained, who are certified, who are all over the United States and Canada, who hopefully there's someone close to you who could come and do an analysis to see what is giving you symptoms, if you have any, what is causing the sounds you're hearing with their meters that we taught
I
them.
appreciate that. But I just want to say, I mean, I've been an analyst in government my entire career. Let me just say, I'm referring something, and if this sounds like it's going to help that person, I'm using an RF meter. My light flashes green while I still feel some other stations that I believe is come from up above.
Okay,
And
Lydia,
so
you
I
could have
think-
electric fields, you could have magnetic fields in your house, you could have dirty electricity in your house that's affecting you.
Well,
But okay, so to discuss the sky,
Sure.
the frequencies of signals coming from satellites do not easily penetrate a roof even without
Okay.
shielding.
Well, thanks.
Because-
And I have shielding. I have the fabric. I have that strong fabric, etc. And I try to make a quasi, that Faraday cage. And I've been really effective to definitely, well, any RF, because I use my phone when I turn the power on, and I wipe out. I go to green again when I make sure the edges are pretty close to touching on 4 sides. So anyway, okay, I thank you. I agree. I will find an expert to help. That's the phenomenon. It's something that's not registering on the RF meter. And I do have I also have the gigahertz meter as well. And
Well, Lydia, all of us, Mitch, Rob, Larry, myself, and other building biologists who are on this call and out in the, who are practicing, get calls every day from people such as yourself who call us up and say, I am sensitive, I have a meter, here's what I'm feeling. 1 meter's low, but I'm still having symptoms, and we come in and we find other EMFs that they don't know about. And so it would really be helpful to have an evaluation by someone who can ask you the questions and make a determination of, we have nighttime EMFs and daytime EMFs, outdoor EMFs, indoor EMFs.
And other satellites too, I think. I have a friend who's a physicist who's been helping me a bit, telling me a bit.
But physicists have one point of view and building biologists have another point of view. So
Okay, thank you so much.
you're welcome. Erin, you have a question, ma'am. Go ahead and unmute yourself and ask your question, please.
Okay, can you hear me now?
Now we can hear you.
Sorry about that. I came on a little bit late, but thank you so much. Just recently purchased and received the millimeter wave meter.
Great,
And-
where are you?
Well, right now I'm in a rural area. My home is
Great.
in Ohio, and
Ohio, okay.
became extremely hypersensitive. In fact, I've got blood work that's I'm not real happy about right now. So right now I'm in a little refuge up here. I'm in a little place in New York. So there are some macro towers. There's a small 5G, a 5G small cell down the street further than where 2 are near my home in where I live in Ohio.
Have you measured these 5G small cell antennas with your millimeter wave and meter yet?
No, because I just got that, and I haven't been back to Ohio yet, and I am anxious to do that.
Oh, you're in New York. I think I heard you say, right?
Yes, but I'm gonna meter around here to get an idea. Although it's further away, the towers, because it's more in a there's some mountains, if you want to call them mountains, they're kind of eroded, but there's more macro towers. Whereas in Ohio, which is a streamlining state for rapid deployment, it is merciless the amount of small cells, macro.
But Erin, we
everywhere.
have to remember, just because the industry says that they need to put millimeter wave 5G antennas in front of every third house to get proper coverage, that doesn't mean that they're going to put them there in front of every third house. I mean, Mitch and I were talking about that yesterday. I mean, the amount of money that it takes to put up one of these installations is tens of thousands of dollars.
Well, there's
They're not,
within 200 feet of my home, and then that's north. And then if you go south of my home up at the high school, they've put massive antenna on 3 different light poles, one of which caught fire in 2007.
okay, but Aaron, it's probably 4G.
I agree. I think it's something, and I agree.
But that doesn't make it
spoken with-
safe. I mean, let's,
No, exactly. That's exactly my point. And so I guess I probably more of a comment, but I would be interested in your opinion, because there seems to be around both my property and in my home, but especially on the property outside. So what I have found is I have a neighbor who has 2 neighbors who have roof solar panels with inverter boxes. I have another neighbor who has a police radio. There are within 700 feet, massive antenna up at the high school. And within 200 feet north of my home, there are 2 5G small cells that may be.
Okay, all right. Before you get into 5G, what do you measure with your Safe and Sound Pro 2, and what do you measure with your millimeter wave antenna? Outside, it's a hypothetical question. This is what you need to do.
Yeah.
Doesn't matter what's down the street. It could be pointing in another direction. Those antennas are very directional. What matters is, what do you measure outside of your house and inside your house? That's all that matters with these different meters. That's
Correct.
all that matters.
That's what I've done.
You understand what I'm saying?
I think I do.
It's very important not to worry about what's down there. You have to see what is the reading where you are.
Exactly. So I have not had the chance yet to get back to Ohio with the new meter, with the millimeter.
Well, what did you measure with your other meter when you were there?
It ranges and it changes. It's not static, it's
It always
dynamic.
fluctuates.
Right. And so it
But
is
hundreds, thousands of microwatts?
thousands. And in my
And what
home,
meter do you have?
I have the Pro 2.
Oh, good. So outside your house, you were measuring in the thousands?
Yes. And I walked around the block and
Oh,
I
that's not good.
stayed on the sidewalk.
You were getting thousands of microwatts in your yard?
Yes.
Oh, that's not good.
No, it's not.
And your EHS,
I am now.
electrically hypersensitive?
I had an acute onset. I had an experience in the middle of the night. And I've been
Okay, that's not
medical
good.
diagnosis. No, it's not good, which is why I'm where I'm at right now. I have a nursing background. So no, I'm not pleased with what's happening. And I really do appreciate what you're doing and with these meters, because it's very difficult trying to explain to people with the symptoms. And
I say it's not, and I don't mean to interrupt you, but from a meter standpoint here,
Yeah.
it's, shielding is not going to be easy for you. If you're getting
That's right.
would you agree, Rob? Thousands of microwatts measured outside of her home.
Yeah.
Impacting on her windows and her walls with
Yeah,
wood
it's a
frame
challenge
construction.
for sure. Yeah, it's a challenge. Yep.
Yeah.
So it's been, yeah. So there's a lot to consider. And, I have tried to take it up with, the mayor, the
Good luck
building
with that.
commissioner, the
That's
director of
not,
public
that's going to be
safety, the
going
city
nowhere.
council, the
Uh-huh.
director of building facilities at the high school.
I mean,
And
the only
there's
way that you can ever have any success with that is if you nip it in the bud. If you have to get the planning commission to deny the permit before it's issued. Once that permit's issued, I think I can count on one hand the number of people worldwide who have been successful at taking down towers that I've read about. But once, in the US or Canada, once a permit is issued, and especially once equipment has been installed, there's a contract between, Crown Castle, which can do all that leasing, and then they'll get the permits, they'll buy the equipment in collaboration with these companies, and then they'll lease, up there, they'll co-locate to Verizon, T-Mobile, AT&T, Dish, or those companies will own it outright, do it themselves. But once they put that equipment in, it never comes out. No, you have to shield or move. If you're EHS and you have thousands of microwatts outside of.
Yeah, so there's a measurement the area that I live, it's an older neighborhood, but it's a nice neighborhood, and it's one of the nicer neighborhoods. And so our homes, though, it's a very traditional neighborhood. The homes are, small little properties, and there's blocks. And so right at the end of where my property and then my neighbor's driveway is at, there is a utility pole across the street with a transformer, and that registered over 7,000 right
Wait,
there.
wait. Transformers have nothing to do with RF.
So, but okay, well, I'm
No,
just.
no,
that-
no.
that-
Apples and oranges,
Okay,
different
so-
EMF.
Okay, well, where I was standing directly across the street, there is that, but directly down the street, 1, 2, 3, maybe 3 houses down is where the newly installed, activated, about a year ago. And I'm calling it a 5G small cell.
You
for
call
lack
it, please call it a cell antenna.
Call it a
We
cell
don't know
antenna?
the
Okay.
generation.
So
We
they
don't know what the
installed
technology-
they put a pole up and then they put 3 antenna at the top.
Okay, probably 4G primarily. There could be
Okay.
5G mixed in. Doesn't
Okay.
matter really at this point.
But standing right in the direct line of sight of that, so that's what the reading was there. And, you know,
What was the reading?
7,000.
7,000. Okay. And
Yeah.
how many house lots are you away from that? 2?
From the cell tower?
Yeah.
I am within about 250 feet, maybe.
How
200
many
feet.
house lots? Like 3, 4?
So I am the 5th house on that block, and then the towers, excuse me, the poles.
That's pretty strong.
It's very
Because
strong.
you're going to get several hundred, if not 1,000 microwatts on the inside of that room coming through the window, especially.
Yeah. So yes. So
See, what you want is if somebody says to me, I go to a job, I drive in, and I get my gear, and then they say, well, we have a cell tower, it's down the block, but they've got 4 houses in between, and I don't pick anything up because the signal has been attenuated and weakened by all those walls, all those buildings. But if I go out in the street, I can see it, and then my meter goes way up. If you can see the cell tower can see you. If you can't see the cell tower, then you have some natural shielding just from the buildings in between as well. But it sounds to me like in your house, you said there's a hill or something, and you can see that antenna, at least in front of your house, down the street.
well, that's a
right?
straight line to that one. And then when you do go up the hill, the high school then would be, up the hill right at the corner. However, where those big light poles are with the big antenna on them, you can see those. I can directly see those.
Okay, you can see them out your windows.
Oh, absolutely.
Okay,
Which is-
all
so
right.
there's
Well, that's
real
not a good.
convergence of
So-
stuff going
So
on.
Aaron, this is turning into, as with many individuals, you need to consult with someone who can help you with this. You can call Rob's company directly. Again, go to the buildingbiologyinstitute.org website, click on find an expert, then certified consultants, then electromagnetic radiation specialist or building biology environmental consultant, which is first, and look for somebody in Ohio. Where are you in Ohio?
Well, Rocky River, right by, close to Lake Erie.
Near Toledo, near Erie then. Or no,
No.
well,
No,
what,
no, by
Cleveland or-
a suburb of Cleveland, yeah. Mhm.
Cleveland, okay. We have people up there, we have students in that area. We could work, but you need to have somebody to guide you on shielding. You need to shield or move. It doesn't sound good. The combination of your symptoms and the degree of the strength of the signals that are coming in. And I'm
Just-
glad you're getting the meter, because then you'll know what the situation is with the millimeter wave meter. But probably the predominant signal you're getting is with the classic, which is the low and mid band. And there could be
And-
5G mixed in, but just it's all cell signals at that point, 4G and 5G mixed together.
Does
So-
one quick question. What about DE, dirty electricity from solar panel inverters?
It's a whole nother conversation. It goes from house to house, comes in on the wires, radiates off the wires a few feet into the room. It's dirty electricity is really electric fields at higher frequencies radiating off the wall. And there are inverters that have less N-phase microinverters and solar edge and some say Sunny Boy as well. But anyway, Aaron, that's
you.
a whole nother conversation.
Thank you very much. Thank you.
Okay. Lisa, you're next.
Hi, thank you guys so much. Rob, congrats on this new meter. It's very exciting. And thank you all for the work that you're putting into this webinar. I have a question. I live in a condo and I'm just curious for people who live in condos and apartments, what should we anticipate or think about with these 5G millimeter waves from our neighbors' routers or cell phones or other devices? And
No, it
how much
no, it
goes
doesn't
through
happen.
walls? It doesn't happen.
No,
It doesn't go through
no,
walls.
no, hold on. There's no millimeter wave transmission from a router. There's 5G from a router, which is 5.8 gigahertz, which is abbreviated 5G, and it confuses the heck out of a lot of folks, and understandably so.
Sure. So what things can penetrate that are not currently measurable on the safe and sound meter that we would need this blue meter, or is it something that will happen in the future that we need to anticipate? Right now I have shielding up, it's great, but I have some very high-tech neighbors here and they will have all these, latest and greatest gadgets. So I'm just curious, what do we anticipate? What will we need that meter to measure?
Rob, you want to answer that?
Yeah, we're still in learning mode on that, and we're waiting for input from all of the beta testers and all the people that have the millimeter wave meter to find out what sources are really out there. We don't know right now. We're learning. The things we can say though is the 5G high band transmitters. If you have one of them outside of your window, that would be an issue. We know that we're picking up signals from car radar systems. So that's another issue. I'm just going through my mind trying to think of other sources right now. And there can be point-to-point dish communications. If you're between two dishes that are talking to each other, they typically transmit at 10 to 22 gigahertz, somewhere in that range. But actual appliances and actual devices that use those millimeter waves at this point in time, I'm not aware.
Well, there is some 60 gigahertz Wi-Fi.
Oh, good point.
That's in use now. It's all being formed. In the first learning session on June 28th, I gave a PowerPoint presentation with some slides of a client of mine who lives on the 7th floor of a 7-story apartment building, who, like the first lady, has antennas right above her roof. And I had measured very high 4G signals in her bedroom, in her living room from that. But she has a millimeter wave 5G antenna right across the street. And you can see photographs of that and videos that I took at ground level and then up on in her apartment and on her little balcony there, opening the sliding glass door. She's getting some very strong 5 millimeter wave 5G activity coming into her apartment, not through the walls. It's coming into the glass, a sliding glass door, and then reflecting off of the other wall and into some space where she wasn't directly in front of the window. So there's some reflections in there. So you can see that video and you'll see the measurements that I took on the replay of the previous learning session.
Right.
Okay, so it sounds like if a neighbor is using a cell phone next to one of those antennas, that could come through. But if there's no antenna outside your window and someone is using a cell phone, we don't need to really be concerned about that at this point.
Yes, you do, but not from the millimeter wave signal.
Yes. Yeah, I'm only talking about this upper millimeter wave that I've never measured before and haven't felt inside our condo, but just anticipating how I might use this meter in the future.
Well, how high is the condo? How many stories?
Oh, we're way high and we're not near, we have a courtyard. We don't have any antennas outside. I'm just more curious about my neighbors who use a lot of high tech. If I need to anticipate any of their activity.
No, not, I don't know anything on the horizon or in use now, Rob. That
even if there was, it would stay pretty contained. It would be limited basically to the room that you're transmitting in if it's above 20 gigahertz.
Yeah, it doesn't go through walls.
It's very
That's awesome.
Yeah.
Great.
I think we're pretty good when it comes down to that part of it. Yeah.
This is mostly an outdoor phenomenon, guys, but it is coming into rooms through glass, like a sliding glass door. If you, this lady had an antenna right across the street pointing right at her building. So.
Right. For all those people, they're definitely, if they're sensitive, would need to move to if they have one out. I am in the city. One other quick question. So I've noticed that the antennas are very strong that are on the light posts, et cetera. And from your presentation, Oram, I'm assuming now that it's because of the 4G, not because of the 5G millimeter waves.
Hold on. When
Mhm.
you say you've noticed that they're very strong, do you have a meter, Lisa?
Both feeling and meter. Yes.
Okay, well, I very much respect and appreciate your input as an EHS person. And just to help understand where what you're being affected by, what do you read, what meter are you using and what reading are you getting? Do you have the green safe and
Well,
sound
so
code?
my question is, yes, I have the safe and sound meter. I have the acoustimeter. I have
Okay, and
the
what
gigahertz. And
okay,
it is coming in very high. Sometimes they'll be at like 100,000, et cetera.
Oh.
I'm just curious, from your measurements, you reading and doing the studies, which were great to watch. I'm assuming from your readings that I saw that most of the RF, and from what you've said, is coming from the 4G
Oh, by far.
antennas. And I was curious if you notice, because I feel that they're very strong. They feel a lot stronger than what you might feel from.
They're always on, Lisa.
Yeah, and I was wondering if that's proximity.
Oh, yeah.
Because they're so close, versus is it because some of these now have 5G millimeter high band waves coming out? And I think that answer is no from your presentation, but I just
Well,
wanted to double check.
No. The 5G is not a good development. There's no question about that. The only thing that I have difficulty with as a practitioner and as someone who, as an educator, is this notion that this focus on 5G to the exclusion of all the other stuff. See what I'm saying? The lay public in the EMF community is just focused on 5G without understanding what the physics are, how it works, what frequencies it involves, and seemingly ignoring. I literally have people who say, "Oh, I'm not concerned about my cell phone, Oram, but I'm really concerned about the 5G," and they don't even have it, but they have 14 wireless devices and they have symptoms. And I say, "You got to help me with my headaches," and it's all 5G. That's all they think about because that's all they're reading. Anyway,
I think I've just been excited. I don't have this new meter, the blue one, yet. I've been excited that it was going to come out and we can kind of see.
It's very
because
valuable.
we don't know if these antennas that they've been putting up have been turned on or not necessarily. And so because you now have this meter, I was hoping you could shed some light on, are you seeing, and it seems like it was just validating from your presentation that 5G is not turned on in a lot of these, the upper millimeter wave is not turned on a lot of these antennas yet.
What? No, did I? No, I didn't have that thought at all. So I'm curious to know why you came to that particular conclusion, if I may ask.
I think that I was trying to follow along with your presentations, and that was my assumption. I'd love to know what you found then. Why are they feeling so strong?
Well, when you say turning on, I didn't know it until I worked with Mitch 2 days ago, that the activity of my phone, which happened to be a Verizon phone in front of a Verizon antenna, would trigger the beamform signal to come at a much higher level to give me, and the speeds were, slower before that came on. And then when that came on, the speeds were much higher. Any app, any activity on the data side will trigger that upshift in terms of the transmitted energy. Is that what you mean by was turned on, wasn't turned on?
I think, Oram, with you traveling, I think you traveled 40, it was 40 blocks or so, but you only found 1 millimeter wave 5G transmitter in that range. Is that correct?
But in the purely residential neighborhoods, Rob. See,
Okay,
look,
I see.
what I recommend that everyone at all levels in our EMF community, the people that the top activists, the top advocates, the people who are really spearheading this, and my colleagues in our profession, the building biology profession, we understand this, and they've heard me suggest this before, and that is, we really need to focus on the technology and oh gosh, I forgot my point. But just the fact that the 5G is not, oh yes, it's not happening at the millimeter wave level in residential areas. And here's why: because of the physics involved. It doesn't penetrate into houses, and they know that 98% of the population in the residential areas inside their homes, people are using Wi-Fi calling. All 4 companies allow that now. And so if you have a better connection for your voice calling and your texting and your data through your Wi-Fi than to the tower down the street, then that's how you're going to do it. And so they don't need to spend $50,000 or $100,000 to put these 3 antennas and then the radio down underground and all the permitting and the cost of that. They don't do that in residential neighborhoods. They'll do that in commercial areas where there's a lot of foot traffic. The people who can access these high speeds are those who are on foot outside of a building. That's where I've found this. The crackling or the tick 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 sound is only there. And one exception in a residential area, which actually was about 2 blocks from one of these major, 3 blocks from one of these major roads. But I did say deep in it, and I didn't realize how close I was to the edge of that residential section. But all the others are on Wilshire Boulevard and Hollywood Boulevard and Washington Boulevard, the boulevards, a lot of traffic, a lot of people, a lot of foot traffic. Does that make sense, Lisa? I know you muted yourself, but that's
in the lead stage, like when you guys.
That makes sense. I was just curious to hear your summary and make sure I got that right. And I think I'll be looking forward to hearing more and seeing more when you guys broaden the study and find out more what is the 5G millimeter waves affecting people versus, the 4G that they're continuing to boost.
Yeah, well, 4G is getting more advanced, more modulated. I have clients, I've read accounts of people who are EHS who say, I have a Verizon 4G antenna in my neighborhood. I can walk the dog. I've been able to do that for years, no problem. The truck came by, they did some work, and it may not have even been 5G. It could have been 4G advanced, just upgrading but more modulation in terms of how they shape the signal. And then the guy said, after that guy left in his truck, ever since then, I cannot go out there without being affected. And it's just, more modulated 4G advanced. It doesn't have to be 5G. It's just cell activity, which is all getting more modulated. And then there's the activity
your
on the
point
phone.
is that's happening everywhere, this upgrading.
Yes,
And
of the 4G.
Millimeter band is not happening everywhere.
Can you repeat that, Larry?
I'm saying that the upgrading of 4G to more highly modulated signals, which affects people more adversely, is happening everywhere, but 5G is not happening everywhere. It's happening
in the millimeter wave band.
Downtown, in the millimeter bands, is happening, as you said, in downtown areas where there are significant numbers of people outside where it can be used.
So if you're in a residential area and you don't see and there's a particular shape that you saw in the in both of the slides that I've done in the presentations. If you see the more tall, skinny, those are 4G elements. And you measure either with the green meter or you don't, and you measure it with the blue meter or you don't. But if you're deep in a residential area and you don't go out of that residential area very much, you're EHS or you're in the country, you're probably going to be okay. But if you are EHS and you work with people, you're a consultant, you need one of these meters. And if you go into commercial areas, you need to know, because they are pretty prevalent in populated areas.
Hey, Tony.
That's the value.
No, thanks everyone. Tony, I'm just doing a time check here. I think we're over 2 hours now, and we should probably think about shutting her down at this point.
Rob, may I just ask a quick question?
Yes, Nancy, I saw your hand up. Real quick.
It's about, there's been a few questions in the chat, and I've been wondering this too about vehicle radar. Especially I'm wondering how wide the beam is, how far it goes. I was injured by EMFs a little over a month ago. I couldn't figure out what happened, and it turns out it was from heavy equipment that was being used by my neighbors next door. And we're still trying to figure out what the frequencies were from that. But obviously it was the millimeter frequencies because my Pro 2 didn't pick it up. But now the neighbors have a new car and they're going by, and I'm sure it has radar. And I'm wondering, how far do I have to be away from that when they're driving by in order to be safe?
That's a good question, and I'll start with it. And we just had some feedback from a tester in our area, and driving down one of our major highways, the 401 in Ontario, Canada. It's a divided highway, and there's a decent median in between. It's a ditch, probably about 30 feet wide, and we're still picking up signals of the vehicles traveling in the opposite direction. You know, every few vehicles, there would be another reading, and we would be reading, you know, between 10 to 30 or 40 microwatts per square meter. So that tells me the width or the scatter is quite wide. I would imagine right in front of the vehicle would be the most concentrated part of that radar. So
do they have it in the front and the back of the vehicle? So backing up and in front, Rob?
Well, there's going to be blind spot sensors as well too, which is at the sides.
Oh no.
Yeah, I would think that the back of the vehicle primarily would come into play when they're backing up. In the front of the vehicle, there's collision sensors, so that definitely is coming out the front. There's the adaptive cruise control, which is coming out the front as well. So I'm just, you know, the more of this testing is needed to figure out the beam width of what's happening there. And what we're measuring is the legacy, I think, radar, you know, around probably 24 gigahertz. We still think that a lot of the newer cars are broadcasting at 75 gigahertz or in the 70 gigahertz range. So we're not seeing that at this point. So yeah, we need to learn a lot more about this and get feedback from all the testers out there and try and do some tests to see how wide these beams are.
And you think they go quite high off of the ground, or are they staying like 8 feet? Any ideas on that?
It would be hard to, if they're spreading, you know,
yeah,
on angles left and right, I'm sure they're spreading up and down as well too, and reflecting off of certain things. So I'm going to guess they're probably going up a couple stories as well. It just depends on how far away from the vehicle it is. But the signal, like the further you are away, the less amount of impact you're going to receive, or the power density is going to decrease the further you are away from it too. So that's a factor that comes into play, but it's out there. We need to learn more about it.
Hey, Rob, since we're drawing to a close, there was some discussion earlier about people working with their local officials about regulations for the installation of these towers. And I wanted to provide to the folks a copy of the original brief, Friends of the Court brief that the Building Biology Institute prepared, which has a great deal of data in about what happens when you expose people through case studies from, you know, feet on the ground, as well as some background information about the regulations and how far they are from the truth, and also some information about the costs of shielding, which impose huge amounts of monetary costs on people who want to protect themselves while the companies make money, you know, from the positioning of these towers. So I'm going to stick those two. One was 2008, the other one was 2022, I think. Those two briefs, Friend of the Court briefs, into the chat now.
Okay, great, Larry. That'll be good information for everybody to have. Tony, maybe we'll leave the meeting open a little bit on its own until, so people can have access to this this information that Larry's going to deposit in the chat. Tony, you want to sum up and finish up the meeting here and draw some conclusions?
Yeah. Am I muted? Not muted. Yes. I was going to say I've been putting it in the chat, our phone number and our email address. Also included our blog. We have lots of Oram stuff up on our blog, and lots of 5G information. A lot of the questions you guys were asking is available on our website. So if you want to take a look through, it's all there. And again, you can call or email us anytime during our business hours if you have more questions. Our support staff is all educated and have good knowledge on this stuff, and they're all EMF certified. So I think that's it for us, Rob.
Okay, great, Tony. So Larry, are those items entered into the chat at this point?
Yep, they just went in.
Okay, so let's give the attendees a few minutes to grab that information if they choose to, and maybe shut down in about 5 minutes or so, Tony. But yeah, everyone, thanks for attending. Really appreciate you guys being here. We all need to learn more information about this, these new signals that are coming out. Oram, thanks for all those observations and videos. It's great to see that in action, because a lot of us can't see it in our own areas. So that's great to see. And we hope more building biologists come out with more videos and examples of measuring 5G, because, you know, we all need to learn more about this topic.
Yes, we very much look forward to hearing what all of you measure in your own towns and cities, and with your cell phones, and whatever you can share. It's really valuable. So we fully understand this, because 5G is top of mind of people in the EMF community, and I dare say, and I say this with great respect and love, a lot of misunderstanding, and so we're trying to respectfully correct that understanding to make it more accurate within our community, and also particularly when we interface with those who are outside of the EMF community. We want to look like we know what we're talking about. So because there's a lot, and it's very complex. There's no doubt about that. It's difficult to grasp this. It has been for decades, and it hasn't gotten any easier. It's very complex now. So, but Rob, he knows this business. He's an electronic technologist, and he and his team with Bruce and others have come up with a really a good set of meters that are easy to use, and they get feedback from us in the field and put it into the constantly reviewing the design of their meters. So kudos to you guys for coming up with a great meter that really works in the field.
Thanks very much, Oram. Really appreciate it. And Tony, I will give you the controls to sign off whenever you see fit.
Okay, Oram, you're stopped recording.
Okay, I will do that now.